Hello everyone, I am Dr. B. Vijay Babu. Today I am going to discuss the topic cache memory. Cache memory is an extremely fast memory that acts as a buffer between the main memory RAM and the CPU. It is used to speed up and synchronizing with high-speed CPUs. Cache memory is considered than main memory or disk memory, but it is economical than CPU register. It holds frequently requested data and instructions so that they are immediately available to the CPU when needed. Cache memory is used to reduce the average time to access the data from the main memory. The cache is a smaller and faster memory which stores and copies the data from the frequently used main memory locations. There are various different independent caches in CPU which stores instructions and data. Cache memory can be organized at different levels. For example, in the diagram we can see the cache is organized at 3 levels. All the levels of cache memory are faster than the RAM or the main memory. The cache which is closer to the CPU is always faster than the other levels, but it costs more and stores less data than the other levels. Level 1 or L1 cache memory is located very close to CPU or the processor or can be built on the processor chip. L1 cache is the smallest in size and it's very fast because it almost runs on the speed of the processor or the CPU. Here the L1 cache is made with the material, the static RAM ICs. We can see in the diagram the 3 levels of caches are placed between the CPU and main memory, and as we can progress away from CPU, the caches becomes slow. The L2 cache memory is larger but slower than L1 cache. L2 cache is also found on the CPU. If L1 and L2 caches are used together on the CPU, then the missing information that is not present in the L1 cache can be retrieved quickly from the L2 cache. L2 is usually a separate static RAM or SRAM chip, and it is located between the CPU and the DRAM, that is main memory. Coming to L3 cache, L3 cache memory is an enhanced form of memory present on the motherboard of the computer. It is an extra cache built into the motherboard between the processor and the main memory to speed up the processing operations. It is an extra cache built into the motherboard between the processor and main memory to speed up the processing operations. Now, let us try to understand the terminology cache hits and cache misses. When the CPU wants to read or write a location in main memory, first of all, it checks for the corresponding entry in the cache. If the processor finds or the memory location is in the cache, a cache hit has occurred and data is read from the cache. Otherwise, if the processor does not find the memory location in the cache, then a cache miss has said to occur. Coming to cache performance, the cache performance is measured by defining the parameter hit ratio, or we also call it as cache hit ratio. The cache hit ratio is given by hit ratio is equals to number of hits divided by number of hits plus number of misses, that is equals to number of hits divided by total accesses. For a cache miss, the cache allocates a new entry and copies the data from the main memory and then the request is fulfilled from the contents of the cache. But here, the data cannot be copied directly into the cache location arbitrarily. The location of the cache memory into which the entry has to be done is to be mapped with that of the main memory location entries. This process can be accomplished by mapping or cache mapping techniques. We have three cache memory mapping techniques. The first one is direct mapping, the second one is associative mapping, and the third one is set associate mapping. In direct mapping, assign each memory block to a specific line in cache. If a line is previously taken up by a memory block, when a new block needs to be loaded, then the block is trashed. An address space is split into two parts, index field and tag field. In associative mapping, it is used to store content and addresses of memory word. Any block can go into any line of the cache. This means that the word bits are used to identify which word in the block is needed, but the tag becomes all the remaining bits. This enables the placement of any word at any place in the cache memory. It is considered to be the fastest and the most flexible mapping form. Set associative mapping is an enhanced form of direct mapping where the drawbacks of direct mapping are removed. Set associative addresses the problem of possible trashing in the direct mapping method. It does this by saying that instead of having exactly one line that a block can map to in cache, we will group a few lines together, creating a set. Then a block in memory can map to any one of the lines of a specific set. Set associative mapping allows that each word that is present in the cache can have two or more words in the main memory for the same index address. Set associative cache mapping combines the best of direct and associative cache mapping techniques. Since the size of cache memory is less as compared to main memory, so to check which part of main memory should be given priority and loaded in cache, it is decided based on the concept of locality of reference. There are two types of locality of references. One is spatial locality of reference and the second one is temporal locality of reference. In spatial locality of reference, there is a chance that proximity or close proximity to the reference point, or there is a chance that element will be present in the close proximity to the reference point, and next time if again searched, then more close proximity to the point of reference. In temporal locality of reference, least recently used algorithm is used. Whenever there is a page fault occurs within a word, will not only load word in main memory, but complete page fault will be loaded, because spatial locality of reference rule says that if you are referring any word, next word will be referred in its register. That's why we load complete page table so that the complete block will be loaded. So this is how basically a cache memory works. Thank you.